A student determined the relative molecular mass of an unknown volatile liquid Y in an experiment as shown in figure 5. The student used a hypodermic syringe to inject a sample of liquid Y into a gas syringe in an oven. At the temperature of the oven, Y was vaporised. The student's results are shown in table 2. Okay, and then what we're being asked to do is define relative molecular mass. So let's do that first because that's just a learnt answer. So it is I'm just going to say MR equals the average mass of one molecule, and then we want that relative to, so I'm going to do a divide for that, 1/12 the mass of an atom of carbon-12. Then it says use the experimental results to determine the relative molecular mass of Y. It's given us the gas constants. That's kind of a hint that we're probably using the gas law. So what we've got here is we've got the masses before and after. So we can do a subtraction to find the mass of Y. So we're looking at our results, 10.91 and 10.70. The difference between those two numbers is 0.21 grams. We're going to need that later. That's the mass. The temperature, 98.1 degrees C. Let's turn that into Kelvin. So we're going to add 273. We get 371.1 Kelvin. And we've got the pressure. So this was our T, this is our P, and this is our V. 102 kilopascals, which we need in pascals for the gases, and then our V was 85.0 centimetres cubed, which we need in metres cubed, so we're going to divide by 1,000,000 times 10 to the minus 6 metres cubed. So if PV equals nRT, and we've got the P, the V, the R and the T, we're going to calculate N, so PV divided by RT. I'm going to put our numbers in, 102,000 pascals, 85 times 10 to the minus 6 metres cubed, divided by R, 8.31, and T, 371.1. We're going to put that into our calculator, and we're going to find out that that comes out to be 2.81 times 10 to the minus 3. That's the number of moles of Y, and so MR is mass divided by moles. So we're going to take the mass that we worked out was 0.21 grams, and we're going to divide it by our moles. So we're going to take our 0.21 and divide by 2.81 times 10 to the minus 3. That is going to give us 74.7. The number on the calculator is longer than that, but we were just bearing in mind that these numbers in the table had 3 or 4 significant figures, so 3 is the appropriate answer. And also MRs in the periodic table, the data is given to 1 decimal place, so giving our answer to 1 decimal place is also an appropriate way to give it. So 74.7. The next bit of the question says some of the liquid injected did not evaporate, so if it didn't evaporate, the volume would be lower, the volume in the gas syringe would be lower, but the mass would be the same, M same, but V lower. Explain how this would affect the MR. Okay, so because less of it evaporated, we get a lower volume recorded. Now, if you look at where volume was in our calculation, it was on the top line. So moles calculated is less. How does that affect the MR if the mass is the same? But if moles is on the bottom now and it's less, then the MR would increase.